Welcome to 1.5. This section we're going to focus on multiplication and how it relates to the concept of area. So we're going to focus on all the aspects of multiplication and go over several of the related properties as you can see here in the keywords. And so let's just dive right in. So the first thing to talk about is what even is multiplication. So I think most of us have done some kind of multiplication before, but let's think about what we're really saying. So when we're saying something like 4 times 400, 4 times 400, we're saying we'd like you to run, in this case, let's use an example of 400 meters. We'd like you to run 400 meters 4 times. You could run 4 meters 400 times, but for some reason that doesn't sound like as much fun. So we're going to do 400 meters 4 times. And in this case, you could think of it as a relay. So we have a total distance of 4 times 400, even though each athlete's only competing in 400 meters. Now, you could think of this multiplication as repeated addition, and in fact, that's what it is. So 4 times 400 means 400 4 times. And so if we add these up, I get all zeros make 0, all zeros make 0. 2 fours is 8. 2 more 4s, another 8. So 8 and 8 is 16. So 1,600 meters, 1,600 meters, which of course relates to 4 times around a 400-meter track. And again, I could have done this the other way. I could have done, 4 plus 4 plus 4 plus 4 plus 4, right? 400 times, but the math would have been much more difficult and I would have gotten the same result. And so let's talk about what we're actually going to do when we multiply. So what we're going to do when we multiply is we're going to multiply the numbers by first stacking them. And then essentially what we're going to do is we're going to multiply so that every place value in this lower number, in this case there's only one place value, the ones, is going to multiply to every place value in the upper number. So 4 times 0 is 0, 4 times 0 is 0, 4 times 4 is 16, and sure enough, that checks out with what we get when we add it up. And so that's how multiplication works. Multiplication is repeated addition. It says it right here, and you might have heard it before. And what we're going to do now is look at how to do that when maybe the numbers aren't quite so nice. So let's define a couple of terms. The big new term that we have is factor. So a factor is one of the numbers that's used to multiply by another number, another factor. So a factor times another factor, and in fact, let me back up here and do this somewhere where I have enough room. A factor times a factor equals a product. So the result of addition is a sum, the result of subtraction is a difference, and the result of multiplication, a factor times a factor, is a product. Now, here's something to be mindful of, the multiplication sign. So multiplication sign. So there's a few of them. The x is the classic, although we're going to shy away from using that partly because we start using x as a variable in a lot of our pre-algebra and algebra. So that's one option, the x. That's okay in the whole number section, but I'd really like you to move toward a couple of different options. One is the dot, Another is to use parentheses, to put one of the numbers in parentheses. Okay? And then, as we'll see, if you have a number and a variable, or two variables, you actually don't even need a multiplication sign between them, because putting them next to each other means multiplication. So you won't be confused. Every time you see that, it won't mean add, subtract, or divide. It'll always mean multiply. And so let's look at a couple of examples here. I could say 3 times 2. I could say 3.2, or I could say 3 parentheses 2. And all three of these mean multiplication. They'll all produce 6 as a result. And so when we talk about multiplication, we're talking about the product. And just like in addition and subtraction, the order, the and here, it shows you where the multiplication sign is, and then the numbers go on either side of it. And the product tells you, oh, that we're multiplying. So if you see product or you see factor, you know we're multiplying, or it's somehow related to multiplication. Okay, one of the biggest concepts in multiplication is the distributive property, and it's pretty neat. Here's how it works. Let's take some numbers that I know. So let's see here. So let's do something like this. 2 times, let's say, how about 14? 2 times 14. Well, if I don't know what 2 times 14 is, that's okay. Here's what I can do. I can break that down into its component parts. So I can say, okay, well, 2 times 14 is actually the same as 2 times 10 plus 4. Here's what's neat about this. 10 plus 4 is 14. So I could add those two. 10 and 4 is 14. And the parentheses just mean multiplication. So I could get back to what I had. So far, it means the same thing. Here's what the distributive property allows me to do. It allows me to say, when I want to multiply by something in parentheses that has addition or subtraction on the inside, I can distribute the number, the factor that I want to multiply, to the terms inside. So I can say that's equivalent to 2 times 10 plus 2 times 4. And I like to use parentheses here because not only do they take the place of the dot in multiplication, they make sure to kind of remind me that I'm not really done here. So I've got some work to do. Because right now it just says 2 times 10 plus 2 times 4. And I got that by distributing. Right? So I can multiply here. 2 times 10, that's one of the facts that I know a little better. That's 20. 2 times 4, that's 8. What's 20 plus 8? 28. So we got from 2 times 14 to 28 by using the distributive property, which says anytime you're multiplying numbers, you can break down one or more of those numbers into component terms. And so in this case, let's see, 2 times 14. 2 times 14, well, that really means 14 2 times. Add it up. 4 and 4 is 8. 1 and 1 is 2. Oh, nice. It checks out. So the distributive property is a great way to multiply if you don't necessarily know what the result is going to be. One of the reasons it's really handy is, for example, 4b here, that says if you're multiplying and you can't add, then one thing you can do is distribute. And that will at least get rid of the parentheses. So this is 3 times x plus 3 times 2 instead of 3 times x plus 2. So that's 3x plus 6. And so you could think of adding up x plus 2 3 times, but what would you do? If you added up 3 2's, you'd get 6, and 3 x's, you'd get 3x. So this is a really handy way for us to not only work with algebraic things with variables, but also just to do kind of bigger multiplication. If you're not 100% sold on this idea, let's do an example here. I'm just going to erase some of this example. So let's take a classic example, like say a Super Bowl party. Maybe last year you brought crackers and cheese to the party. Right, you brought it in a little Tupperware, so that's what the parentheses are showing. That was a package. You brought crackers and cheese to the party. This year, because it was so popular last year and it ran out, you've been asked to bring twice as much. Now, what does that mean? If you're asked to bring twice as much cheese and crackers, you better bring twice as many crackers and you better bring twice as much cheese, right? Because otherwise it wouldn't be equal. And you'd have crackers left over or cheese left over. It wouldn't be twice as much cheese and crackers. And so that's kind of one nice real-world example where you can say, okay, this distributive property makes a lot of sense. Okay, the multiplication property of 0 also makes a lot of sense. It says whenever you multiply by 0, the result will be 0. And here's a way to check it, let's do this. 3 times 0, what is it? That's right, it's 0. And you can check yourself. You can say, okay, well, let me add this up. Let me add 0 up 3 times. That's what 3 times 0 is. 0 plus 0 plus 0, that's 0. Okay, yeah, so 3 times 0 is 0. Now, what about 0 times 3? So you have nothing to add up. So then you have nothing. So whether the 0 is in front or in the back, if it's a factor, your product will be 0. A sort of related idea is the identity property of multiplication that says anytime you multiply by 1, anytime 1 is a factor, it's not going to change the result. So let's look at an example like, how about 3 times 1? Well, what's 3 times 1? Oh, that's 3. And you can think of it a couple different ways. You can think of 1, 3 times. 1 plus 1 is 2, plus 1 more is 3. Or you can think of 3 once. Well, that's just 3, right? And I'm adding it to what? That doesn't even make a lot of sense, right? It's just 3. 1, 3. So whenever I multiply by 1, whether it's in the front or it's in the back, the result will remain unchanged. And this is really handy in algebra. Not so much for multiplying by 1, but often for dividing. And we'll see a lot more of that. And so this is a really good property that comes in handy. Another property that you've probably actually already picked up on is the commutative property of multiplication. It says if you change the order in multiplication, it doesn't change the product. The order of the factors doesn't matter. So if I have 3 times 2, well, that's 6. And if I have 2 times 3, well, that's 6. Because whether I add 2 3 times or I add 3 2 times, I'm going to get to 6. So the order in multiplication does not affect the result. Now, the reason that's handy is because it can help us to, it can sometimes help us to rearrange things to think about them. So in this case, we're going to visualize the commutative property by thinking about a dining room with 8 guests. So we have a couple of different seating options potentially. We could have 4 tables with 2 people each, 4 two-tops, or I could have 2 four-tops. Those are kind of 2 different ways where I can get 8 guests. Now you might say from a restaurant standpoint, that actually the 2 tops are a little bit more manageable because you've only got 2 dishes coming out simultaneously. Whether the 4 tops, you've got 4 dishes coming out, but the result, the number of guests dining in the evening, that's the same, and that's kind of the important takeaway here. So the reason this is important, and the reason this exercise asks you to do things like to rewrite an expression to show the commutative property, is because sometimes you get multiplication in an order that you don't like. And one of these, 4 times 6 or 6 times 4, one of these may be easier for you. For instance, for me, I prefer this one, and I think I prefer 7 times 9, 19, I think I prefer 7 times 9 as well. So I prefer the left-hand side for thinking about these problems, right, in recalling my multiplication facts, but they are equal to the left-hand side. That's equally valid. Another important property is the associative property, and it says, sort of like the associative property of addition said, if you're multiplying, then the way you group the factors in a product doesn't have an impact on the result. Now, this is only true when it's all multiplication. So if you've got 2 times 3 times 4, you can think of that as 2 times 3, then times 4. Or you can think of that as 2 times 3 times 4. So 2 times 3 is 6 times 4. 3 times 4 is 12. 6 times 4 is 24. 2 times 12 is 24. So I get the same result, whether I group the first 2 or the last 2. But this only works when it's all multiplication, and it can be handy. For instance, I think that maybe the right side ends up being easier because 3 times 4 makes 12, and 12 is easier to double than maybe remembering the 6 and 4's times tables. So you know your own skills best, and so you can make a decision about, well, how do I want to approach this problem? In what order do I want to do this multiplication so that I can get it done and be more confident that the result is correct? All right, let's dive into some, hardcore multiplication problems. So we've got this one, 9 times 43. And whenever I'm stacking the multiplication, I like to put the longer number, the one with more digits, on top. And that's because I'm essentially going to multiply the bottom number times both place values in the top number. So what I do is I start by saying 9 times 3. That's the step 1 here. I'm sort of following along step 1. 9 times 3, well, that's 27. So I'll write the unit that's in the ones place, and I'll carry the tens. Now, before I do anything with that 2 in the carry, I have to multiply 9 times 4. So what I'm going to do now is I'm going to say, instead of multiplying 9 times 3, now I'm going to multiply the 9 times the 4. But, let's see, 9 times 4 is 36, but then I need to add the 2 more that I had carried over. So 36 plus 2 is 38. And so I have 387, and that's the result of 43 times 9. How about this one? find the product of 279 and 428. So since they're both three-digit numbers, it doesn't matter which one I put on bottom, which one I put on top. I'm going to have to multiply each digit in the bottom number, the lower number, to each place in the top number. And so I'll start on the right with the 1, so 8 times 9. 8 times 9 is 72. Carry the 7. 8 times 7, well, 8 eighths is 64, so 7 eighths would be 56, plus 7 is 63. Bring the 3 down, carry the 6. 8 times 2 is 16, and 6 more is 22. So what I did there is I multiplied 8 by 279, and I did it by multiplying 8 times the 9, 8 times the 7, and 8 times the 2, and I carried over and added any carryover that resulted from my multiplication. So whenever you multiply and you get more than one digit, it's going to have to carry over somewhere, and it carries over to the next place value. And so let's have a look at the next part. Now that was just 8 times 279. Now it's not just, remember the expanded form of 428? The expanded form is 400 plus 20 plus 8. And the distributive property says I have to multiply, each part times the 279. So that's essentially what I'm doing. So now I'm going to multiply the 2 times 279, but I have to remember it's not just 2, it's really 20, right? Because the 2 is in the tens place, it's 28. So to show that, every time I move left a place value in one of the factors, I have to add a 0 in its product to represent I'm not multiplying 2 times 9, I'm multiplying 20 times 9. So 2 times 9 is 18. I should get rid of these little carryovers from the last round. So 2 times 9 is 18, but 20 times 9 is 180. 2 times 7 is 14, and 1 is 15. 2 times 2 is 4, and 1 is 5. Now I'm not done yet. I've got to do the 4 times 279, 4 times 9, 4 times 7, 4 times 2. But remember, it's not 4, it's really 400. So I'm not going to move over 1 or 2, or rather I'll put 2 zeros to show I'm moving over 3 places, right, to the third place value, the hundreds. So it's not 4 times 9, it's 400 times 9. So 4 times 9 is 36, and 400 times 9 then is 3,600. That's what this is telling me. 4 times 7 is 28, plus 3 more is 31. 4 times 2 is 8, and 3 is 11. And since I don't have anywhere left for that to come down, it's just going to go straight down. Now, I do have commas here to help me stay lined up. And what I have here are the subproducts. I have 8 times 279. I have 20 times 279. And I have 400 times 279. So what I have to do to find the total product is add up all my subproducts. So what's nice about the ones place is it's usually just whatever was in the ones place because the rest are zeros. 3 and 8 makes 11, carry the 1. 1 and 2 is 3, and 5 is 8, and 6 is 14, carry the 1. 1 and 2 is 3, and 5 is 8, and 1 is 9. And bring down the 1 and the other 1. There's a comma there. And there's my final result. The final multiplication result of 279 times 428. Okay, so let's have a look at a practical application. Could be nutrition facts. So on the back of every or most food products, there is a nutrition label, and it will tell you what a serving size is, both by weight and typically by number in the case of something like crackers that we're looking at here. And then it'll tell you how many servings there are per container. So what's really neat about this is we can figure out, well, a couple of things. One is we could figure out how many crackers there are total. There's 27 crackers per serving, and there's 9 servings, and these are approximations. It does say about 27 crackers, so sometimes it's 26, sometimes it's 28, depending on whether they're light or heavy for the day, right? There's some variation in all food products, but about 27, so 9 times you could get 27 crackers out of your Cheez-Its box. So we can either add up 27 9 times, we could add up 9 27s, or we could multiply. 9 times 7 is 63. Carry the 6. 9 times 2 is 18, and 6 is 24. So 243 crackers, Cheez-Its, in the box approximately. Now we can do the same thing for calories. If there's 150 calories per serving, and there's 9 servings in a box, then 9 times 150 would be how many calories there are total in a box of Cheez-Its. Let's find out. 9 times 0 is 0. 9 times 5 is 45. Carry the 4. 9 times 1 is 9, and 4 is 13. So 1,350 or 1,350 calories in a box of Cheez-Its. Now notice what I did. I labeled these because this is a real example problem, and so it's important to make sure that I'm putting the context in that I was given. So another cool way to think about multiplication is area. So if I have something like 2 times 3, whoops, let's try that again. 2 times 3. Well, I know that's 6. But one way I can think of it is as inches. So if I have 2 inches on one side and 3 inches on another side, then if I were to divide this up into its inches, and then go around splitting this up, I can see that there's 1, 2, 3, 4, 5, 6 square inches in my figure. And so what's really neat about multiplication is you can kind of think of it, well, you can totally think of it as area. So if you have something like 2 times 3, there's the 1, there's the 2, here's the 1, here's the 2, here's the 3, right? 1 times 1 is 1. Well, 1 times 2, well, that's 2. Okay, yeah, so 2 square units. 1 times 2, that's also 2, so 2 square units. So it could go 1, 2, or it could go 1, 2, right? Those are both good options. 2 times 2, well, that's 4. And that makes a square, which is kind of interesting. That's because 2 times 2, a thing times itself, we'll say later, is squared. 1 times 3, well, that's just 3. And 2 times 3, well, that's 6. And I can see here, oh, 2 times 3, it is 6, actually. It really is, both mathematically but also visually, physically. And so area is a measure of the surface, the flat surface an object has, typically something like the inside of a house or something like that, right, is often how we think about area in terms of square footage or something like that. But we can think of it in a whole bunch of different ways, all of which is related to multiplication. So a couple of common shapes, some facts from geometry to refresh your memory. A square. So a square is the same side or same length side all the way around. So often we'll say it's a side times a side, or a side squared, and we'll use this exponent here. We'll say s squared, which literally means a side times itself, right? whatever you have, multiply it by itself. So if you have something like 3 squared, that means 3 times 3, which is 9, which is what you get if you take 3 and you square it. 1, 2, 3, 1, 2, 3. So there's 1, 2, 3, 1, 2, 3, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's why 3 times 3 is 9. 3 squared is 9. Neat. Okay, and then for a rectangle is really, just, it's sort of like maybe the square started as a rectangle and then it got perfect, right? So the rectangle sort of applies to all rectangular shapes, no matter how uneven they are, no matter how skinny and narrow. As long as they're rectangular, they meet at a right angle. Then you can multiply the length, one side, times the width, another side, that meets at a right angle, and you'll have the area, length times width. And we saw that in the previous example with 2 times 3. So here's a really good example of why area is helpful. Imagine you have a house. You could think of adding up your square footage by measuring, oh, my kitchen is 9 by 14, so I have that box. And I have a bathroom that is 5 by 14. And then I have a master bedroom that's 17 by 14. And I can think about all these little smaller sub areas. So that's kind of neat. I can add up all those little sub areas, sub products, and then I'll get the total product. But maybe a better way to think about this is as one big shape, one big rectangle, for the most part, with a small addition. So I really just have 2 big rectangles, and we can see that here in the drawing. So then if I add 14 plus 23 plus 13, I'll get 50. And if I add up 9 and 5, 17, then I'll get 31. And then I know my deck is 7 by 13, so I label that separately. And so now I can calculate my total square footage. I can say, well, my total area is actually equal to the length times width of the interior part plus the length times width of the exterior part, the deck. And so what I'll do is I'll multiply these products separately, and then I'll add them together. So 50 times 31, I can think of that as actually 5 times 31 and then add a 0, right? So 5 times 31, 5 times 30, 5 times 3 is 15, so 5 times 30 is 150, right? 550 times 31. The distributive property would have us thinking of it as 5 times 30 plus 1, and then we're going to add a 0 at the end because we know we're really multiplying by 50, not 5. So 5 times 30, so that's 5 times 30, plus 5 times 1. This is what's going on in my head when I say 5 times 31. 5 times 30 is 150. 5 times 1 is 5, so 155. Add a 0, 1550. Seven times 13. We can do the same thing over here. 7 times 13 is the same as 7 times 10 plus 7 times 3, the distributive property, right? So 7 tens is 70. That's an easier one. 7 threes is 21. That's a smaller one to memorize in my multiplication facts. 91. In this case, I don't have to add a 0 because I wasn't multiplying by anything that big, right? I wasn't multiplying with anything with a 0 to have to kind of take it away to make it easier to add it back at the end. This is just 91. Now here's a good opportunity for estimating. 91's close to 100, so my answer should be close to 1650. And in fact, I know it's going to get into the 16s, and it's only 9 away from 1650, so that means it's 1641. That sounds right. Now, 1641 what? Well, that's area of my house, so that's going to be in what? Square feet. A couple of different ways to do it. You can do it like that, or you can say feet squared. Those are both good options. All right, couple of problems to inspect here. We're going to solve these. So let's look at A. 6 times a number equals 24. 6 times what? 6 times 4. 6 times 4 equals 24. How about B? 4 times a number equals 36. Yeah, 4 times 9 equals 36. 15 equals 3 times a number. 15 equals 3 times 5. So that number is 5. All right, D, 21 equals 3 times a number. Well, that number has to be 7. So these are some of your multiplication facts. You want to be sure to practice them because they are important. So explain how multiplication is shorthand for repeated addition. Like we always do, go ahead and take a second to answer all of these questions yourself and then come back and see the answers. Multiplication is shorthand for repeated addition because it tells us, the multiplication sign, the dot sign, tells us, as in that original example we looked at, it tells us how many times to add up the other factor. So in this case, this is equal to 400 plus 400 plus 400 plus 400. In other words, 400 added up 4 times. And so that's the relationship between multiplication and addition, is that multiplication is repeated addition. Okay, use the variables a, b, and c to explain the distributive property. Well, it says if you have something and you're multiplying it by something else that is the sum of 2 other things, you can distribute the factor in front to the 2 terms inside parentheses. And as long as you multiply the first factor to each term, then your answer will remain equivalent. So this is A, this is B. C, explain how you would find the area of a flat object. Well, if it's a flat object that is rectangular, then you could simply multiply length times width. And if it's a square, then length and width would be the same. And so that's why we think of it as side squared. And if you had any other object, then you could break it down into smaller rectangular pieces that you could find the length times width area of, and then you could add all those up together. What is the difference between the commutative property of multiplication and the associative property of multiplication? Well, the commutative property above says we can multiply a factor to the 2 terms inside parentheses, or more terms, whereas the associative property says the order in which we're multiplying doesn't matter as long as all we're doing is multiplying. So if I have to multiply a times b times c, I'm going to get ABC as my product, whatever that turns out to be. And whether I do A and B first, or, because I like the numbers, I do B and C first and then multiply my A, it will get me the same result. So hopefully that has been a good review for you of multiplication, and I'll leave you with that, and we'll see you in 1.6.